Hello, everybody. Welcome to today's webinar, Heat Pump Water Heaters, Builders Share Their Experience. I'm Joe Wachunas. I'm a project manager at the nonprofit New Buildings Institute and a passionate volunteer at Electrify Now, here with my usual partner in crime, Brian Stewart, the founder of Electrify Now. And we are so excited because today's webinar is being hosted by three organizations, Electrify Now, the Advanced Water Heating Initiative, and EEBA. And we've got Aaron Smith, the CEO of EEBA, and Nancy Bakeman as well from EEBA. So we're going to hear a little bit to start us off about each of these three organizations, then we'll dive into our amazing panelists today. So Nancy, go ahead and take us away and tell us a little bit about EEBA.
Thanks, Joe. EEBA has been around for 40 years. This is our 40th year. It was founded in 1982 as a nonprofit focused on education and mostly building science education. We've grown to a community of about 70,000 members across North America and beyond. And as I said, we've always been focused on building science, but now we're moving towards healthy, electric, resilient, decarbonized, net zero homes. And we're excited to be part of this group today to talk about heat pump water heaters.
Fantastic, thank you. Great, and then the other organization, which I represent today, is the Advanced Water Heating Initiative. This is an initiative that exists to promote and accelerate the deployment of heat pump water heaters. And I think we're all pretty interested in this technology since we're on this webinar today. The Advanced Water Heating Initiative sees this game-changing opportunity of heat pump water heater technology because they use 25% of the energy of old electric resistance and gas water heaters. And so we have this moonshot goal at the initiative to get to 100% water heater market share by 2030. We're in the single digits right now, but we need big ideas and big moves given the state of the climate crisis. So I'll go to the next slide. We've assembled, a group of over 400 organizations across the country, from governmental organizations like the DOE and EPA to utilities, nonprofits, manufacturers, everyone, all these partners working together to promote heat pump water heater technology. And today is a webinar example of that. So please, it's nonprofit run, and all of our meetings are free to join. We have working group, task groups. Go to advancedwaterheatinginitiative.org. I'll put in a link in the chat. And then I want a special shout out to any builders on today's webinar. We are forming a Builder Action Council as a spinoff of today's webinar with EEBA and Energy Star. And we want to hear from builders, connect with builders, and hear about how you're deploying heat pump water heaters. And we're going to hear from some builders leading the charge today. But we're doing a home builder roundtable with heat pump water heater manufacturers on August 18th. I'll put an email address to info@advancedwaterheatinginitiative.org to get more information on that. We want to connect with you, so please connect with us. Okay, Brian, tell us about Electrify Now.
Thanks, Joe. Yeah, Joe and I both work with Electrify Now. We're basically an education-focused volunteer organization, really trying to help people understand the really amazing options we have in terms of our energy choices, which not only reduce our carbon emissions, our personal carbon emissions, but also help transition the world to a clean energy system. And so we try to make it simple for people by breaking it down to these 3 steps. And there's tons of information on our website about how to do this to get clean energy into your home. Then electrify your home by basically getting rid of anything you have that burns fossil fuels. We're going to be talking about one of the big ones today, water heaters, and then electrify your transportation. And then it's also important that we remember that some people may struggle with this transition and we can't leave anyone behind. So we really want to urge people to remember about policy and philanthropy that helps to electrify everyone. And by doing these actions, you can save or avoid a ton of over 20 tons easily for a typical household, and also enjoy a safer and lower cost household. We've started this Electrify Coalition, which is a group of over almost 50 organizations now, primarily in the Northwest, focused on electrification, promoting electrification. If you're interested in joining us, let us know, send us an email. It's no cost to join, but all of us help create some of the content that you'll see in our webinars, but also help promote electrification. And then I want to thank all those of you who may have contributed. We got some really good contributions. We ask people if they're so inclined to donate to the Electrify Everyone Fund, which we have set up in partnership with Community Energy Project here in Portland. This is an amazing program that removes old gas water heaters in low-income homes and replaces them with free heat pump water heaters. It saves these families hundreds of dollars per year on their utility bills and avoids over 25 tons of carbon for each water heater we've installed, and we've put in over 50 of them so far and hope to really accelerate this program going forward. So thank you for your contributions. All right, so let's enough for the intro. Why are we talking about heat pump water heaters? Let's start really big picture. I think most people get the idea that your car creates carbon emissions. You can see it, you smell the gas, you see the smoke coming out of the back of your car, but most people do not realize that our homes, they're heated with natural gas, produce more emissions than a car does. And the gas comes from a lot of the same places, you just don't see it. It's piped in, and the flames are in your basement maybe, and the smoke's coming out of the chimney, you don't really see it. So it's harder to understand and appreciate that those carbon emissions are happening. The two biggest culprits, so to speak, or the things that generate the most emissions in most people's lives are your gas furnace, about the same as a car, and your gas water heater, which is surprisingly high emissions given, how small these devices are. So that's why we're going to be homing in today on water heaters. And the solution for this, whether you have a gas water heater or even an electric resistance water heater, is to switch to high efficiency heat pumps, because they're literally 3 to 5 times more energy efficient. They look a lot like regular water heaters. We'll hear a lot more about this today, but they operate because they have this heat pump on top of them that utilizes the energy from the space around them to transfer heat into the water at an insanely efficient way. So that's why we're interested in heat pump water heaters. And Joe, tell us about what we're going to be covering today.
Yeah, so we're all fans of heat pump water heaters, but at the Advanced Water Heating Initiative, we've surveyed folks and stakeholders from across the country, and folks feel like the lowest hanging fruit is to put heat pump water heaters in new construction. So that's what we'll be talking about with our builders today, because you're building a new home and you can design it around a heat pump water heater and easily install this installation. It's just easier to do than retrofit. So let's start here and make all new construction include heat pump water heaters. But so we're going to hear from our panelists today on why builders are excited about heat pump water heaters and why you should be too. What are some of the challenges and roadblocks for installing heat pump water heaters, and how do we overcome them? Are builders modifying their home to take advantage of the heat pump water heaters? We'll hear about that. Exciting. And what are homeowners saying? And any guidelines that can be applied to new or existing homes. So maybe you're not building a new home, but what can you do with this information about heat pump water heaters? And any way to communicate the benefits. Most people don't think about their water heaters, but we're all pretty excited about these. So how do we communicate about them? So let's go and introduce our panelists. We have a rock star, all-star panelist today. We're going to start with Jeff Wicks, who's a senior product manager at NEA. Jeff works closely with utilities and trade allies to help identify and prove out innovative energy efficient technologies to transform markets. He currently supports heat pump water heaters, connected water heaters, and actively scans on other motor-driven products and water heating technologies. I work with Jeff all the time. He is an amazingly intelligent person. So he'll kick us off with a study on just how much air space do we need to heat water for a heat pump water heater. Then we'll move on to two folks from Ichijo. We got Amy Tovel and Masaki Narita. Amy has been working with Ichijo for more than 10 years in marketing and land acquisition. She brings awareness of Ichijo's unique building features to the public through marketing their energy efficient building practices, cool in-house contemporary designs, as well as unique proprietary products. And then we'll hear from Masaki, who has been working with Ichijo for over 28 years and it's transferred to Portland from Sapporo in Japan in 2016 to oversee operations in Oregon. Designing homes in the Northwest is both challenging and enjoyable to Masaki. So after hearing from Ichijo, then we'll pivot over to the Southeast with Leah Dickens from the Greenbelt Alliance. Leah works as the Green Building Program Manager for Greenbelt Alliance, North Carolina's nonprofit for advancing sustainability in the built environment. She manages their Greenbelt Homes Certification Program and previously worked for Deltec Homes as their Green Building and Building Science Manager. And then we'll close it off with Juan Fernandez, the founder and CEO of CVF Homes. Juan founded CVF Homes in 2005, focusing on infill development and building energy and water efficient homes with great design. CVS Homes is committed to certifying 100% of its homes as DOE Zero Energy certified homes. And Juan will be talking about his experiences installing heat pump water heaters. So that'll give us about 20 minutes for Q&A. Go ahead and put your Q&A. Some folks are already doing that in the chat, and leave your comments in the, Q&A in the Q&A button, comments in the chat. And let's turn it over to Jeff to get things started.
Great, thank you, Joe. And this is going to be a whirlwind tour through all this. So what
Jeff,
I want to do.
We don't see your camera is not on, Jeff. Sorry, we're not seeing you.
Okay, wow, that is a problem. I thought we had it on.
We see your slides, but
there we go. Thanks. So I'm Jeff Wicks. I work for NEA, the Northwest Energy Efficiency Alliance. We're mostly focused here in the Northwest. But for those builders who are familiar, check out that medallion there that I'm pointing to on my front porch. I live in an all-electric home. Everything in it is heat pump, and we are net positive on our generation with our solar system, solar arrays. We're going to talk about heat pump water heaters and some of the challenges, but I want to first go over a couple of things. Where can they be installed? What are the best locations? And if you have less than optimal space, what are some of the strategies for doing this? And why should you include heat pump water heaters in new construction? So briefly go over garage, conditioned and semi-conditioned spaces, ideal location. If you have a water heater in a garage right now, it is not freezing, and you will provide additional cooling in that garage and or desiccation because of the nature of heat pump water heaters. And you're just transferring heat from that garage, either from a car or from just the general space. Basements and crawl spaces, conditioned and non-conditioned, no brainer, easily done there. Utility rooms with more than 700 cubic feet. As you can see, that's not a huge utility room, but it's substantial. And or if it's a utility room that is open to other parts of the house. Mechanical rooms with plenty of volume or excess heat off of a furnace or a whole house heat pump. Any attics that are above freezing and below 120 degrees would be a perfect location. Some of our friends in the Southeast and in Texas put water heaters in the attic. In the Northwest, we don't do that, but that's a viable option. Hallways closest, hallway closets that have good ventilation, but are not directly near a thermostat location. Location matters because you don't want to be blowing cold air out onto a thermostat and having the whole house do a call for heat. So what do heat pump water heaters need? Proper voltage. You need a 240 volt, either 30 amp or 15 amp. So in new construction, that's an easy wire pull of 10 gauge, three conductor. Sufficient makeup air. This just needs to be enough air for the water heater to breathe, and that we'll get in a little bit into that with a study we just finished. A solution for disposing of condensate. This is not toxic condensate. It is not like a gas furnace that produces basically sulfuric acid, and you have to treat that. This just produces water, and it can be dumped into a standard drain or out into a garden. Then you need thermal isolation so that you can have access to lots of, you don't want it to be in the out of doors unless it's an environment. Then you need sound isolation as well if you don't want it right next to a bedroom or an area where people are concentrating. And then you need to have a desire to save money for the resident and reduce their energy footprint. So those are what we need here. So the physical space is a challenge. Makeup air, discharging the cold air can be a problem, and then condensate mass and noise separation can be a problem. So what do? We did some research. I'm not going to read this all to you, but it's called the Amazing Shrinking Room study, where we put a water heater into a space, and I'll show you a couple images of it here shortly, and compress that down to see how small can you go and what can be done once you have a small space. So this was done in a lab in Redwood, Washington. It's basically 1,000 cubic feet in the center picture. It looks like basically a container, and that pink wall moves back and forth, and you can compress that space, and we can see how they do. We verify and validated that all the tests that we've received and done do operate at 700 cubic feet or less, and that's part of our qualified products list. We then compress that space down to the far right-hand picture, which is a closet of about 84 cubic feet with a louvered door. And then we did different permutations with that, with sealing half the louvered door or opening grills and that kind of thing. There's a couple more pictures. Here's a plan view of that study. So we moved this wall back and forth, and we verified and validated performance. We also have full data logging equipment on this, both for the interior space, the water temperature, and the amount of energy that was used. This is generally a volumetric test. Won't read all of this to you, but we see an inflection point at 700 cubic feet. So what the manufacturers have been saying about 700 cubic feet being the magic number, it's truly there. But I also want to point out in this lower bar here, an electric resistance water heater is about 0.9495% efficient. You're still doing a better job than electric resistance, even if you put it in a small closet and you basically suffocate it, because it will automatically flip over onto an electric resistance. But this magic point of 700 cubic feet is where we want to have for volume access. It doesn't have to be, it has to be fully open. You can do some grills and ducts. So this is, as we showed you earlier, this is the closet, and these are the different experiments we did. You can see grills high and low and how this fan gets vented and directed. A lot of information in here. I encourage you to look at our study to go through the details of it. This is just some other solutions and fails. So we found that ducting actually can be a great thing, or it could be a real problem if you have insufficient duct options for it. In the next slide, you'll see all the different permutations that we looked at. So here you can see what the standard performance is, wide open with more than 1,000 cubic feet. It's right at 3.5, and now some of them are as high as 4.2. And then once you start constraining that space, it starts getting tighter and tighter. But remember, standard electric is at 1.0. So you're, even with all these other strategies of grills high, grills low, ducting in, ducting out, half of a louvered door, a full louvered door, where you point the fan, all those things will make a difference. So the next slide just shows all the different permutations. I'd encourage you to look at the study once it becomes published, but there's an hour-and-a-half presentation if you really want to get into the weeds. But you can see that the net free area is what we're looking for. And it's somewhere around 24 to 36 inches is what you need for a net free area. So that's a pretty small grill that you could put on either a door or a wall. And then you want some vertical separation of those so that you get the thermocline inside the closet area. This is a couple examples, and I'm almost finished here, of where you could put them on interior spaces. These happen to be in multifamily, but you could put it in an exterior closet and vent in and out of there, because they do work as long as the temperature is above 37 degrees. Or you could put it into a hallway within a complex, or you could put it in a hallway of a house. So the next slide is just how to get a hold of me. There's some specifications, some of the research, and there's a full YouTube if you really want to get into the weeds, and I can send that to you. So my contact information is here, and I'll turn it back over to Joe.
Perfect. Thanks so much, Jeff. He distilled a lot of great information into a short time, and we'll get the study, the latest NIA shrinking room study in the chat. It's just really amazing stuff. I do want to say, put your questions for Jeff and our panelists in the Q&A. We do have a funny little hiccup that happened when 3 orgs coming together to promote this event, and it looks like I shared my individual link on the Eventbrite page for folks who signed up through Eventbrite. So you're getting a lot of questions from Joe Wachunas in the chat, which is kind of humorous. You can change your name in the Zoom if you'd like to identify yourself. But let's move to our next panelists, Masaki and Amy. Go ahead and tell us about Ichijo and your building and work.
Yeah, going on our slides here. There we go. Can we see anything? No.
There you go. Yep.
I can see some.
There we go. So we gotta back up here. Go back to the front. Okay. All right, so I'm Amy Tovell. I'm the marketing manager at Ichijo USA and been here for over 10 years now. And Masaki Narita is the VP of our Oregon branch. And who is Ichijo? Well, Ichijo, as you can imagine, is a Japanese company. We're an award-winning Japanese and American company. In Japan, Ichijo builds over 15,000 homes a year. And these aren't spec homes, these are custom homes. So you can imagine that's quite a few homes every year. And we specialize there in energy efficient homes and have won many awards, such as the New Builder Award for Earth Advantage in Oregon most recently. Why is sustainable building important to Ichijo? We have a deep desire to build quality, durable homes. We also want the homeowner to save money. We're environmentally conscious, and it's great for Ichijo's reputation. We have such a large company in Japan that we built a facility in the Philippines where we build many of the items that go into homes, including wall panels, in-floor radiant heating, solar panels, cabinetry, windows, interior doors, and more. And some of that is shipped over here to the United States. We also do a lot of quality control and research and development there. In 2009, we expanded to the United States, and our first stop was the Seattle area. And our first project was one that many of you probably have heard of, Z-Home. This was the first net zero energy townhome community in the nation, built by Ichijo, along with the support of many others. The project earned many awards and has been proven to be beyond net zero, with owners receiving checks of more than $1,000 annually from the electric utility. Pretty exciting. We also built an all solar community in the same city, Issaquah. Each home had solar panels on it, and this was way back in 2015. And we named it Sunridge to go with the all solar name, and won a lot of awards there as well. So I'd like to just discuss a little bit about our projects, and we are all electric now at all of our communities beginning in 2020, so a couple years ago. We're in Washington and in Oregon now. We have 3 communities in Oregon where we're building net zero energy ready homes. And first one being Reed's Crossing in Hillsborough. We have 94 lots. Pleasant Valley Villages in Happy Valley, we have 171 lots. And River Terrace Crossing is about to start with 43 lots in Tigard. In Washington, we've just completed, sold out of a community in Maple Valley, Momiji Grove, 39 lots. 10 Trails in Black Diamond is a planned communities. We have 84 lots we're building there. And Brookdale Phase 1 in Tacoma, we are starting 32 lots now. All and in Penny Lane in Redmond, 18 townhomes. So to date, we have 141 homes equipped with our heat pump water heater, along with all the electric systems. And I'm going to briefly describe those systems and go more in depth with the electric heat pump water heater. So in our homes, we are providing all electric net zero energy ready homes. And this includes the induction range, which is safer, faster, more efficient, cleaner air and cooler temps. the heat pump, heating and cooling system with a 40% savings. It's quieter, and we have the bonus of including air conditioning, which is very popular, especially this time of year. The electric fireplace with heat or without, these are pretty cool nowadays. Real more contemporary designs. So we haven't had any pushback from this one at all. They're pretty cool. And we also provide solar and EV charger ready. The pre-wired for that in our homes. So the heat pump water heater that we're using can get up to 70% potential savings based on the usage of your hot water bill when compared to the standard electric water heater or tankless gas water heater. It's a substantial step to the net zero goals for the carbon footprint of your home. And it's enough capacity to meet the needs of the normal water consumption. So we've had some feedback. We mostly get feedback on all electric systems, not just one in particular, but mostly cost savings. And but the particular feedback we've had on the heat pump water heater is that very quiet. The 666-gallon tank is sufficient capacity. That's what we're using in most of our communities, and the utility bill is overall reduced. The installation, we are installing these exclusively in our garages because we need enough space, enough clearance, this just seems to work the best for us. Maybe Masa can add a little bit more onto this one, but yeah, we haven't had any issues installing it here, and everybody seems to think it's a good location. So what's next? Improve comfort and promote the heat pump water heater. We are looking at including a home energy monitor, solar panels and batteries, demand response program, and incentives for the new home buyers. And that's that.
Perfect. Misaki, is there anything you want to add to that before we, and then there'll be also time in the Q&A?
Yes. Hi, I'm Masaki Narita. I'm very excited to have this opportunity today. And as Amy mentioned, so as a designer, we always put heat pump water heater in the garage. And so, yeah, so in the garage, we have enough space and we have concrete slab that can support, either 66 or 80-gallon tank. Yes, and so for me as a designer, it's very easy to design all electric homes, and also on the dust slide, Amy mentioned about some ideas that we think it could help promote heat pump water heater model. And so I think electric last page. Yeah, I think electric home energy monitor. So yeah, I think this home energy monitor is kind of interesting tools. So with this tool, people can learn how to save the electricity usage. So yeah, so you can maybe make the best of the energy efficient appliances. Yes.
Fantastic.
Yeah. Thank you.
Thank you, Misaki. That's great. Yeah, absolutely. The home energy monitors are crucial. A lot of times we have no idea how much energy our appliances are using, and yeah, having an idea and seeing how much our heat pump water heaters are saving us is crucial. Let's move on, and then we'll also have plenty of time for the Q&A. So Leah, I think you're next up. Thanks so much for being on, and go ahead and share your screen.
All right. So I'm going to take us on a different geographic tour here from the Northeast to the the Northwest down to the Southeast, where I have been working in this industry for the past a little more than a decade. Next. So I'm speaking to you. I work for the Greenbuild Alliance. I'm the manager of our Greenbuild Homes program. We're a nonprofit in Western North Carolina that does education, building science training for builders, and we run our own certification program. So that would be the westernmost part of this great state of North Carolina, which is, I think, a great climate for heat pump water heaters. We're considered a mixed human climate, mostly zone 4, but some zone 5. But it's also North Carolina, and our region in particular, the western part, has a really healthy market for all the things that Nancy mentioned that EEBA is for, you know, that high performance, resilient, healthy, electrified home. We have a lot of customers who really want that. We have a really high participation in the country. As you can see, we're in 2017, this is data from 2017. North Carolina was 3rd in the country for participation in the HERS index and an Energy Star. We even here in Western North Carolina, we have our own Greenbuilt Homes program dedicated to green building. So it's kind of a cool thing. But the other challenge about our market is there's not a whole lot of natural gas availability. I mean, certainly inside a metro area you might be, but where I live, Asheville is the biggest city, and it's not a particularly big city. So if you're building your home in the mountains, as many people are around here, you're not really going to have access to natural gas. So as far as some of the competing technologies, heat pump water heater, like a tankless, that's really difficult to do if you don't have natural gas. So you have this push for that reason as well for electric solutions to be very energy efficient. And the other thing about our market that has been, I think, interesting is there's a really great rebate from the main utility that's specifically for kilowatt hour savings, and it's not an inconsequential one. So just to summarize, like the milieu and politics of North Carolina utility stuff into really fast, there's one main utility that serves both of the Carolinas. It's called Duke Energy. It has a couple of separate arms of itself. And it has, both of those arms now have a program that will give you either 90 cents or 75 cents, depending on where you are in the state, per kilowatt hour of energy saved using, you know, a HERS score, a kind of verification program to builders, up to a pretty high cap, up to 9,000 or 6,000, depending on where you are. And heat pump water heaters are one of many things that you can do in a new home to make it have kilowatt hour savings over, you know, a baseline new home. But it's also, heat pump water heater is probably one of the most effective things you can do to really up that rebate. And so I did an example here comparing how much extra rebate you might get for a heat pump water heater if you were a builder over a standard electric tank, or even over a tankless gas or propane, which again is a common competing, I would say, luxury item that customers want for like a water heating upgrade. And so the rebate can sometimes more than pay for the cost difference. And I have seen builders in our market use this rebate as a way to get a customer on board with upgrading to a heat pump water heater. Hey, I'm going to get this rebate. Why don't you just, you know, do the upgrade and we'll give you that rebate money back to help you, the homeowner, be satisfied with the difference. Some builders, of course, keep that money, help them with their bottom line or to continue what they're doing. But I think this program can be helpful. Currently, it's only in North Carolina, but the word on the street is it's coming to South Carolina pretty quick too. So, and then just giving you my experience, because before I was at Greenbuild Alliance, I worked for Deltec Homes, which is one of Greenbuild Alliance's builder members, also a panelized home manufacturing company. And there I worked on many different homes with this, I would say, high performance, all electric kind of goal. And I will echo what Jeff said. There's a lot of places that really make sense to put heat pump water heater in the Southeast. Garages, basements, if you've got a really tall crawl space, potentially. But I ended up working with a fair number of homes on slabs, believe it or not, even here in the mountains. And then you've got the question of, you know, can you find a way to put it in the living space in a way that works out? So here's an example of one such home, high performance home. So, you know, this idea of a low HERS score. They had all electric, every other appliance, and they wanted to go solar eventually. But they did have a home on a slab, partly for just, it made sense on their lot, and partly because they were trying to take advantage of passive solar design. getting the south facing windows, having that thermal mass. So we had to think about where in their home to put that heat pump water heater. It also had no garage. So basically I've highlighted the mechanical room, and it was right at that 700-foot kind of like borderline thing. And this was actually a stock plan that they took and modified. And I feel like a lot of builders will share this experience, but when clients modify it, they tend to want to make the mechanical space smaller, not bigger. And so that's always a fight you have to have. And that's kind of what happened in this case. They were really trying to squeeze it. So what we decided to do to try and just make sure that the water heater was working well enough for them was we did put a louvered door on this door between kind of their kitchen area and the mechanical room. And in this particular example, I'm not sure if that was the best choice because the homeowners were not happy with that situation. They definitely liked how efficient their house was, but they did complain specifically about the heat pump water heater. I thought it was too loud. So maybe not having a louvered door would have made that less annoying to them, like in the kitchen. Made the laundry room colder than they liked. They actually tried to turn it off of heat pump mode and to electric only mode, but they kept saying it switched back. So that was one example of, I think you got to think through these designs and qualify your homeowners with care. But fear not, I have a more hopeful example. A very similar home, same idea with all electric, passive solar. They ended up being on a slab. They actually were doing solar even as part of their install. So they were really on board with trying to be as efficient, all electric as they could. They also kind of took a stock plan and modified it. So here's the mechanical room. It's actually even smaller than that other one was, but it's kind of adjoining this other sort of mudroomy space. So what we did there was, again, we did a louvered door. We actually put a couple of transfer grills in, both between the laundry room and the mechanical room, and then even between the laundry room and the main room, because that whole front half of the house was heated by a single ductless mini split. So there wasn't direct heating in that room. And because that room was a little bit smaller, we definitely, wanted to qualify those homeowners. But those homeowners really liked it. They thought their house was super efficient. They actually went on and said, I'm not bothered by this. I'm fine with this room being a slightly different temperature than the rest of the house. I think it helped that it was further away from, living areas. We did have to put in a recirculating hot water pump to deal with the fact that that water heater was now really far away from most of the other water fixtures, but they actually liked that feature a lot too. So I think the lessons there would be in those kind of borderline situations where it's, you have to find a mechanical room somewhere in the house to put it. It can be done, but you really got to qualify the homeowners with care. And I have used things like we now have a model home that's got a heat pump water heater so they can actually see it and hear it and determine what they think of it. I recorded a video of one and put it up on YouTube for homeowners to be able to hear it and think, okay, this is what I'm going to be hearing in my house. Am I okay with that? Some random other lessons learned. Condensate. We had another example of if you're putting it somewhere that's not on an outside wall, you might want to think about a floor drain. And we had a situation where we missed a floor drain and we had to put a condensate pump in, and that's noisier than the water heater. So try to not have to do that is the lesson there. I think the other piece of the story with those two examples that I gave you too is that because especially they had mini split heat pumps in the house, those are really quiet. And so the fact that the water heater made noise was more of an issue. So I think it's more of a homeowner discussion about that. And then just some random other tidbits. It may be cheaper at big box stores, but have your plumber supply it because then they provide the labor warranty. And that's important because what I've seen is that if something goes wrong, that's not a really easy thing, like the thermistor, they're going to recommend that you replace the whole water heater, and because no one's going to service it. So it's better just to have a plumber carry that warranty, which a lot of them do if they get it from a supply house. And then just like anything, as you've seen, there's intricacies to the design. So it's good to have an internal checklist in the design stage that, they're not shrinking the mechanical room so much that then it becomes a problem. Even the rough in stage, are you getting the louvered door in if you need it, that kind of thing. And then final inspection stage. As builders know, it's like anything with building science, there's some subtle pieces to it that it's good to have internal processes in place to check for. Okay, that's my part.
Thanks so much. Yeah, fantastic stuff. Great. And we'll have all our panelists, of course, for the Q&A. Juan, let's hear from you next in San Antonio.
Hey. Hello to everyone. Juan Fernandez, CBF Homes in San Antonio, Texas. We're a small builder, mainly in San Antonio and some other small cities close to San Antonio. We are committed to building all of our homes to comply with the Zero Energy Ready Home program from the Department of Energy, and we're very proud that we won in 2019 the Home Innovation Awards. We specialize in infill development, mainly closer to downtown San Antonio. Also do semi-custom and some custom homes. And we try to do better design. That's what we really pay a lot of attention in our projects, to have a great design, because I think that's the cheapest way to get all the energy efficiency and a long-lasting house. However, as we're new to heat pump water heaters, I would like to share with you all about the mistakes that we had installing the first heat pump water heaters. So the ones that we started installing are the Bradford White. These are nice water heaters. The features, we have been including in all of these smart recirculating pump that you can see there in the corner. The features are, as most of these heat pump water heaters, the heat pump, which is the only, it takes a little bit more time to recover for high demand water, and the hybrid, which is efficient, and if you need partly working as electric, it will work at some times electric and sometimes as a heat pump, or electric only if you need a lot of water hot after you drained all the heat pump, and vacation, so that you can just leave it like that, and it will keep the water at only 50 degrees and it will barely use any energy, and it's just for the recovery. But this is our first install, and here in Texas we have hard water, so we were lucky that we had all the houses that we build are pre-plumbed for a water softener. So out of the 6 things that we basically needed to pay attention, we got 2 right out of the 6. So we were able to, we got the 240 right. We got the clearance on top of the water heater right, a minimum 8 inches, because on top of the water heater, there's the fan. And so there's also a filter that you need to change and clean actually. So you need some space. And as you can see, the plumbers, and we work with a big subcontractor plumbing company here in San Antonio, and these were one of the first that they had installed. So they learned with us a little bit of the details to get the heat pump water heaters working. You can see that the expansion tank and also the plumbing on top blocks the filter. So we needed to reconfigure that to be able to access the filter on top of it. Another thing was the condensation line. We installed all of these water heaters in the garage. So we were lucky that the plumbing for the right next to it, for the hard water, the water softener was right there. So we were able to run that plumbing close to it. We needed the 110 as well, because we were installing the smart recirculating pump that we at some point thought it was part of the water heater. On the sides, on the back, actually, we were not clearing the 7 inches minimum that this water heater had according to their installation manual. So we had to move it as well. So all of these were the part of the learning process that we went through on the first heat pump water heaters. Some of the things that we learned is that they do sound like a refrigerator. So you will hear it on the ones that we install. I'm pretty sure that these are gonna be more efficient, and they will be quieter. However, now you need to pay attention on the location that you're installing. Here in Texas, with the Texas heat, you can notice when the water heaters are running, because once you enter the garage, you can feel the garage cooler. So whenever they're operating, you can feel how it's cooling the area. The spacing is critical, as everybody mentioned. So just don't want to bore you it's saying the same thing, but that's some of the things that we didn't know and that we had to change and adapt. But I mean, after all of these details, we're very happy with this, and the clients are more and more asking about the heat pump water heaters. And that's all I have.
Great. Thanks so much, Juan. Really appreciate it. Brian, do you have an initial question to kick us off?
Well, there are a lot of really good questions in the chat. In the Q&A, I was having trouble keeping up, but we'll try to pick them off as much as we can. If we don't answer your question today, you might send us an email later and we'll try to cover it. But a couple here for you. So, Juan, you mentioned this cooling that you can feel from the water heaters, and it's definitely true. It's going to cool the space that it's in. And Jeff, this may be a good question for you, but someone asked about whether the heat pump water heater will reduce the efficiency of the central heating systems in a way that needs to be considered when you're thinking about these. We talk about how efficient they are, and they're amazing. But is there some negative thing that you're experiencing with your central heating system because they're cooling the spaces? How do you answer that question, Jeff?
So very, very good observation. And we found, and we did an extensive study at PNNL Labs out in Richland, Washington, where we compared the use of an electric resistance versus a heat pump in an all-electric home. And we moved the water heater around at different locations. And there was a slight impact in the winter, kind of on par during the spring and fall, and a benefit during the summer. So when this findings were run by the Regional Technical Forum, they said, yep, the savings are holding true at about 1,700 kilowatt hours per year in the Northwest for a water heater. So it's about a wash with your central system. And the reason for that is there's a lot of energy from people living in the house, but also cooking. And the heat pump water heater is able to extract some of that heat out of the moisture, as well as balancing of the heat within different parts of the house with the insulation, and then the radiant heat that's coming in from the outside. So it's not a simple question, but there is a simple answer: is yes, it does impact it, but not as much as people would think, and it's pretty much on the modest side. If you're heating with a heat pump, you're just transferring it from one place to the next. Remember, heat pumps don't make heat; they transfer heat. So if you're heating your home with an inverter-driven mini split or something like that, it's going to be a very modest penalty for pulling that heat from the outside of the building.
It sounds like essentially it feels like thank you, Jeff, that really the consideration is more about how you're going to experience that cooling that happens, and whether that's so like a lot of you have commented on the designs of the house to make sure that doesn't become a problem for the inhabitants. That's more of an issue than the efficiency question, because that kind of works itself out. That's what I'm hearing you say. Is that
that's
fair?
Right. And remember, these don't run 24 hours a day. They generally run anywhere from 2 to 4 hours after a big use, and then they turn off. In my house, because I've got drain water heat recovery, it runs less than 45 minutes because I harvest the heat from the shower wastewater drain that's coming down.
Wow, I think that's we got to get another webinar on that one, Jeff. That sounds awesome. We've got a question from James in the chat, who says and this is for our builders, and Jeff, feel free to comment as well. He's an HVAC specialist and does plumbing. He says, how do we remember that we need both HVAC and plumbing for heat pump water heaters? Do you all agree that in your installations, have you needed just a plumber, or have you had to have HVAC folks as well?
It's varied. We've typically had plumbers install it. There was an HVAC contractor in our area for a while that advertised that they would service them and install them. We were like, great. Because the service was a bit of a worry. Unfortunately, they got out of the residential market. So I think in our particular market, which I would say is in a pretty serious labor shortage in all the trades, it's typically been the plumbers that we've had more success with. I think an example where you have to have both would be if you're doing one that you're ducting in some way. that's certainly a challenge in coordination, because typically you're going to have your HVAC contractor do the ducting. And so you're going to need to vet your HVAC contractor to see if that's something that they are willing to do, comfortable doing, you know, because the plumber's probably not going to do that part. So yeah, sometimes it can be a collaborative effort. And obviously your electrician too, because they're going to be the ones wiring it up.
Joe, I might point out that these are sealed systems. They are not, it's much like your refrigerator. You wouldn't ask for your heating and ventilation contractor to come in and work on your refrigerator. Even though it's refrigerant, you end up taking that out and either servicing it outside of the home or bringing in a full replacement. So I think plumbers are generally the people who know how to handle this the best. They know how to handle the water coming in, the water going out, condensate, and then all the code related to water and pressure and check valves.
We're seeing here in the Portland area, there are a few of the HVAC contractors who are kind of specializing in electrification more broadly. And so they have employed plumbers in their teams to deal with HVAC water heaters, so they can kind of do a kind of complete sort of HVAC retrofit. But that's still pretty rare, I would say. Here, at least here, most of the time, it's the plumbers who are doing that work. There was several of you have mentioned recirculating the hot water pumps. Can maybe there are a few questions just people wanted to know more about what that is. Leah, I think you had mentioned those. Can you just describe that for people and why those are different?
So, and that's actually a requirement, at least at the time of the Zero Energy Ready Homes certification from the DOE, if the water heater is too far away from fixtures. What that does is that's a separate loop that can return hot water from far fixtures back to the water heater. And it's a pump that can pump water through that loop. Otherwise, if the water heater is too far away from your fixture, you turn the water on, you wait like, you know, a very, very long time for hot water to get there. That wastes water, which is upsetting. And it also can waste energy. And so a hot water recirculation loop or pump can be a way to basically it circulates. You hit a button is the idea. If you do it right, and that means it's demand controlled, not like controlled by a timer. You hit a button and engages the pump. It kind of like moves the hot water through this loop, and then you wait till the light comes on, and then you turn the water on. It's hot, is how it worked in that particular home. So it's a way to avoid wasting water while waiting for hot water to get to a fixture that's very far away, which again was relevant for, go ahead.
Does it reduce the lag between getting hot water in those faraway places, or more just about saving the energy?
Should be both. I mean, it's the idea, if it's done right, it should save water and energy, probably more water than energy, but I think it depends on how it's set up. There's definitely it depends on how it's controlled. Some of them will be controlled via timers or via even like sensors, and those have been found to be not as saving on the energy as ones that are controlled by a demand, meaning like you hit a button when you want to turn it on and off.
I would like to mention, if I can, just complementing what Leah just said, that also some of these have these, the recirculating pumps are the smart recirculating pumps. So the first week, they usually learn a little bit of your usage within the house. So they auto-program at what time to run so that they're not wasting energy. So they're not running all the time. So they know that you usually shower at 6:30 a.m. So they will run a little bit before then, and then maybe in the afternoon, according to your, and they auto-program based on your usage of the house.
Thank you.
Jeff, do you want any last word on the recirculating pumps?
Yeah, I think Leah and Juan hit a lot of the really good points. I do want to point out that ones that run continuously can be the death of a heat pump water heater, because they will create a mixed tank, and water heaters don't like a mixed tank, and it will revert to heating with electric resistance. You don't get the stratification. Plus, heat pumps like a temperature differential between the cold incoming water and the hot water going out. So use it on demand if possible. Learning ones, and people like Taco, Grundfos, and Armstrong are the brands to be looking to.
Fantastic. Amy and Misaki, two quick questions for you both. One, folks are interested if Ichijo's going to expand into other states from the Northwest. And then two, maybe speak to, and we could ask all our builders this question, to the brand of heat pump water heater you chose and anything that particularly recommended that brand.
Question? Yes. Likely south and east. But we're in the Northwest, so that's easy. Yeah.
The only place to go.
So yes, we are currently evaluating new locations for a branch office, and it's going to be south, likely, of where we are, or just east. So we've got a few options. The heat pump water heaters we're using in Oregon, A.O. Smith, correct?
Yes.
And
Yes.
I think we were using the Bradford ones here, but we have been notified that we have to start using A.O. Smith because of some kind of facility fire or something like that in their.
Yeah, actually, before before we started using heat pump water heater, we had used gas on demand water heater. That was Takagi brand, and when we started building all electric homes 2 years ago, and at that time, rep of Takagi, Takagi is essentially the, I think, A.O. Smith. He recommended us, yeah, heat pump water heater, and I found it very energy efficient, so that's why we chose, yeah, that brand. But I think, yeah, either any major brand is fine, I think.
Perfect. Thanks, Misaki. Leah or Juan?
I didn't ask before this presentation if it was okay to mention brands or not, so I didn't.
Yeah, we're brand neutral, but just curious for folks. Yeah.
In my totally anecdotal experience, the Rheem ones were quieter. But I think their decibel ratings are actually slightly lower, but I think that's constantly changing as the new models come out. And it's also, for us, always a question of what supply house has it when we need it, you know? So we've used A.O. Smith and Rheem, and I think the Rheem have just always seemed a little bit quieter.
Juan, have you had any experience with anything with different brands?
No, all the ones that we've installed are the Bradford, so we don't know. we haven't tried any other brand.
So there were several questions about refrigerants, and you know, Jeff, this may be a question for you, but unless any of you have experience with this, but you know, there are some makers that we haven't spoken about these, like Sandon, who are using CO2, but they from my experience, they're awesome, but they're quite a bit more expensive, so they tend to be not as well embraced as the other brands. But can you just talk to us a little bit about what's going on with refrigerants for these things? And obviously refrigerants are a big deal for heat pumps, period, because obviously these refrigerants have high global warming potential when they escape. So it's always a concern, but can you tell us a little bit about what's going on in that space?
Sure. Right now, 134A is the dominant one, or 410A, but those do have high global warming potentials. We're going to see a convergence to other ones, lower global warming potential, and they may actually be in the flammable department, if you can believe it. They may be using propane as the refrigerant, but that's working its way through. There's also several other new ones developed by different manufacturers that will be drop-in replacements. One of the studies that NIA and NRDC did was people said, well, we don't want to be using these because of the toxicity to the environment. The reality is if you ran your heat pump water heater for the life of it, which is 12 to 14 years, and vented it right at the end directly to the atmosphere, you would still have an improved GWP impact. So I wouldn't worry about that. People say, well, I'm going to wait until the CO2 systems are more cost viable. I wouldn't do that either, because you're just burning up more hydrocarbons, either in generation or in use, direct use.
I think that's great. I mean, the other thing I just want to point out is, I mean, it's good that people are concerned and they're intelligent about these things, and it's great that we're making progress on, you know, better refrigerants. But remember that your refrigerator is a heat pump, and you've probably had it in your home since you were little kids, and most people don't really even think about, you know, the refrigerants in your refrigerator, but it's the same issue. So I guess my point is, yes, This is an issue that the industry needs to deal with responsibly, but it's not something that as a consumer you should be one bit worried about.
And they are working on it. I will say they're working on it, Brian. They're worried that they want to be on the right side of history on this one.
Yep.
Yeah, not to mention cars,
Yes.
refrigerants, so lots of things that we don't typically think about. There's a question that asked, in your not to do picture, it showed the heat pump water heater raised off the floor. Someone says this is not required as it would be for gas water heater, but please confirm that.
We raised it. I mean, we built it as you saw, as what we did for other type of water heaters. So we built a bench exactly the same. However, I don't think it's needed to have it raised.
So Joe, I'll comment on this. In certain jurisdictions, it is required. They don't discriminate whether it's a gas or electric or a heat pump. They think that there's a spark ignition source in there, and that's why they have to raise it. We've changed that in the state of Oregon, and other states are falling in line because all electric and all heat pump water heaters do not have any ignition source below 18 inches. And it's because of the pooling effect in garages and natural gas ignition sources.
There was another question about the 110 volt water heaters, heat pump water heaters that some people have heard about, that are some manufacturers are in the process of starting to roll out right now. But in the context of new construction, do any of the builders here feel like there would be any reason to use a 110 versus a 240 volt heat pump water heater?
Can I comment on this? I'm sorry to monopolize. I would discourage anybody, if you're going to be pulling wire, just pull a 240 volt circuit. The cost of copper is insignificant. The amount of labor is the same, and just have the robustness of either a 30 amp or now some of the new 15 amp services.
Leah, you were about to say something. Would you agree with that?
I feel like on the order of builders' concerns for getting heat pump water heaters right, the voltage isn't one of them. Like, that's an easy thing because we're already used to sort of dealing with certain appliances being 240.
Yeah.
The only exception that I could think of would be, but the amps may be more important. Then I had a homeowner who was trying to be totally off grid, and they were trying to do all electric. And they did specify a water heater with a lower amperage, but that again wasn't the volt. Like that gets complicated. So yeah. I feel like in general, builders are pretty used to dealing with 240.
Yeah, it seems like those are really, in general, better solution for retrofits. It sounds like.
Yeah. So we heard a little bit about locations on where to install heat pump water heaters in new construction. Ichijo is doing it in garages, and Leah, you talked a little bit about utility closets. Some folks are asking about basements and the cooling effect of basements. Have any of the builders, looked into installing the heat pump water heaters in basements? And Jeff, I know you'll have a little bit to say, but first let's open it up to the builders and see if there's anyone who's installed in basements yet, and then let's turn to Jeff and see what his thoughts are on the cooling effect.
Definitely, if we've got a basement, which for us, because we were custom, just totally depended upon the client and the site, but that would probably be the stronger recommendation if possible. And then the other place in the Southeast where it comes up is crawl spaces, because a lot of homes in the Southeast only have crawl spaces. Heat pump water heaters are unfortunately tall. So if you don't have a tall enough crawl space, then you can't fit it. I think that's a market challenge for the Southeast, but I live in a mountainous region. So sometimes we have super tall crawl spaces, and I've seen them in like conditioned crawls. And they do offer some awesome extra dehumidification in that scenario.
Great. Yeah. Jeff, anything
anyone else
add?
have experience with them in basements? Juan, have you done anything with basements?
No, as also in the South, there are barely any basements in Texas, so we have not installed any in basements or crawl spaces, neither.
Amy, are you guys building basements in your homes?
We do, but we don't install any systems like that in the basement, do we, Masa? I mean,
no, yeah. We haven't.
Just in the garage. It's just easier, I think, the access, and I don't know. That's just where we do it.
Yeah.
Jeff, any last thoughts on the cooling potential for a basement?
We think that basements are a great location. I mean, the ideal first one would be the garage. The next one would be the basement, and in the rank order that I provided in my slide deck. And then laundry rooms, mechanical rooms, and then start going into more challenging installs would be the way to go. But if you can put it in a garage, that's the best. Basements work fine. We've done tons of studies. We've monitored over 120 heat pump water heaters, and a lot of them were in basements, and they perform just great.
Yeah,
We
I'll
have
just
ours in an unconditioned basement, and it's been great down there. And the dehumidification thing, although that's not really a big concern in the Northwest, in basements it can be. And we have definitely noticed that it's helped keep our basement just less humid and, you know, less problems with mold and mildew and that sort of thing. And I would imagine in humid areas it could be a really a real benefit.
Absolutely. I'll just say I finished a tour of, I got to see the folks in Maine, which has the highest per capita installation of heat pump water heaters. And like someone was just putting in the chat, in the Northeast, heat pump water heater, or water heaters are always in the basement. So it's a perfect spot. And that dehumidification is a huge bonus. Great, Brian, do we have a, oh, go ahead.
Majority of our homes are 2-story. I'd say, what do you say? Maybe 10% have basements, Masa? We don't build as many basements here, I guess.
I think you're muted, Masa.
Yes, yeah. We don't build so many basement homes.
Yeah.
About 10%, maybe less. Yeah.
Great, Brian, do we have maybe one last question?
I don't know. Do you have any on your list there, Joe?
There are a lot of questions that we'll try to
A lot of
gather
questions.
these
I think
and
we've
get
covered most of them, but there was
Yeah.
someone talking about surge, or asking about could there be an issue with surge particularly if you're looking for, if you have a battery backup situation, is appliance current surge a factor with heat pump water heaters?
I would say that inrush currents with this is trivial. And there was also another question I saw about phantom loads. There's a minor background load of the electronics that are used that monitor, but it's on the order of less than, you know, a standby losses on a TV. It's minimal. So
Yeah.
I would say don't worry about the inrush. If you're using a heat pump water heater, you will see 450 to maybe 500 watts initially, but then that'll settle down to 350 to 425.
Yeah. Hey, one thing we haven't talked a lot about is that, you know, most of these are Wi-Fi compatible. I know the one that we have, we actually use that feature pretty regularly because it's pretty nice when you're in your car and you're away somewhere and you go, oh shoot, I forgot to turn my water heater down because we're going to be out of the house for 10 days. You just do it right on your phone. Do you see the builders? Do you see that kind of connectivity like that is attractive to homeowners? I mean, is that something that's becoming kind of an expectation, or is it something they just sort of like, whatever, we don't really care about that?
I think that's so dependent on the customer. I think people fall into multiple buckets on that. Yeah, there's definitely some people who think that's awesome. I have one memorable client who was like, you got to wire my house for the future. It's like, what does that mean? Whereas some people, you know, are going to be technical, like afraid of the troubleshooting technical aspects of that. I think builders are somewhat afraid of the technical troubleshooting aspects of that. Like they don't want to be the IT guy for their homeowner like a year later when it doesn't work. I think there's that kind of challenge to it. But yeah, I think some homeowners would find that really helpful.
I did find one more juicy question that I'll put to builders and Jeff. Someone's asking about radiant floor heating and heat pump water heaters. I'll say that I put a heat pump water heater in my test garage unit that we converted to an apartment, and it's got a radiant floor heating system. And it's worked for a couple of years. I'm not sure how much it's going into the electric resistance backup and becoming less efficient. Maybe Jeff, could you comment on using heat pump water heaters and radiant floor, and then the builders, see if any of the builders are thinking about installing?
Yeah, NIA studied a lot of this in both the Sandin and other products. I would be cautious with doing that because you're sending out warm water or sending out hot water, bringing back warm water. Heat pumps don't like that. So I would discourage that kind of a utilization for it. I would get a dedicated heat pump that is going to be providing that kind of work. Domestic heat pump water heaters right now currently sold by the 3 major manufacturers. I would not put them in that application.
I put a link in the questions about, there's a great guide, the Redwood Energy Pocket Guide. We use this a lot. I will put it in the chat. There's oftentimes when I have a question about these kind of more esoteric applications, this is the first place I go. Redwood Energy is really familiar with a lot of these and put together this compendium, and they do have a section on radiant floor heating, I believe, in this guide. I put it in the chat. You can check that out if you're interested, but there's a lot of things in there to study if you're looking at these specific applications. Well, great, Joe. Should we wrap things up? Oh, I did want to ask one more thing, because the other thing we haven't talked about, and I know, Jeff, this is a hot topic for you. Maybe we'll just, do we want to touch on demand response here really quick, just as a one last thing before we go? I know, most people, homeowners may not be thinking about this as really an essential need, but Jeff, can you just touch on why demand response could be such a really important aspect of these things going forward?
Sure. So this is an area that I work on a lot. Right now, people think about storage and renewables. They think of solar panels and batteries. The reality is a heat pump water heater is a far more cost-effective solution for storing energy, far more flexible in that you can heat that water up during renewable periods or low congestion periods of grid time, and then ride through the peak periods of early morning and early evening. So all the water heaters should be coming with connectable ports in them coming forward. It's part of our requirements with the Northwest Energy Efficiency Alliance, but you're going to see this for a voluntary standard with Energy Star, and DOE is probably going to be moving that way. As we become more reliable on renewables, we need more storage. Batteries are great, but water heaters are even better. And as I often say, heat pump water heaters are permanent demand response, and then connectable is shiftable demand response. So it's a great product.
Fantastic. Well, we've gone over, like any good webinar will do. Huge thanks to our panelists, Juan, Leah, Jeff, Masaki, and Amy for their incredible presentations. We'll send out slides in partnership with Nancy and Aaron at EEBA afterwards, and a recording to the video. We want to say thank you so much to EEBA for hosting us. Nancy, any last thoughts from
No,
EEBA?
I had quite a few questions on where it will be posted. We'll have it up on EEBA's YouTube page tomorrow, as well as in our EEBA Academy. So I've sent a few people the link, but you can find it on our website, eeba.org.
Fantastic. Great. And Brian, any last thoughts?
Well, thank you all to the panelists, and thank you all for tuning in today. I hope that was helpful. And I want to wish you all good luck on your electrification projects, and all of you builders out there who might be tuning in. I hope this helps give you confidence to embrace this really exciting new technology. And good luck with all your electrification projects.
Thanks, everybody.
Thank you.